So now it's time to go back and review constant of proportionality. So constant describes how one quantity changes in relationship to another quantity. So a proportional relationship forms a straight line and it passes through the origin, which is 0, 0. So across is our x-axis, up and down is our y-axis. And a proportional relationship can be shown by a straight line that goes through the origin. And it could be going that way, it could be steeper, it could be a negative. Either way, as long as it goes through the origin. So remember, this was way back. This is when we did constant. Since then, we have done linear relationships that did not have to go through the origin. But constant does have to go through the origin. So back when we did constant, remember, constant is represented by the letter K. K equals y over x. This is not to be confused with change in y over change in x. This is simply y over x. And this can be found on your formula chart, and it's called, like the slide is called, constant of proportionality. So the equation for constant of proportionality is y equals kx. There's no y-intercept or anything because it goes through the origin, so that's 0. So this is what we're going to be reviewing today. So let's take a look at a sample problem. The table below shows the prices for a classified ad in a local newspaper. Using the data from the table, what is the price for one line? So let's take a look. So we need to do K equals y over x. So K equals, we'll do the top one, y is 15 because it's always x and then y. So y is 15 over 2. So 15 divided by 2 is going to equal our K. So I can do it in my head. I think most of you can, but in case you are more comfortable seeing the division, 2 times 7 is 14, subtract, I get 1, carry down a 0, 2 times 5 is 10. So it's 7.5. Now if we divided, does that mean that that's our constant? Yes. And is that the amount for one line? Yes, it is, because technically it would be over 1, right? We divided the top and the bottom by 2. So it is B, 750 for one line. Let's try another. A Texas history class is making a scale model of the Sam Houston Monument, which is located in Huntsville, Texas. They plan to use a scale of 1/2 equals 5 feet. Which graph shows the best relationship? So why don't we go ahead and make a table? That way we can know what points we're looking for. So we of course know that if it's proportional, it's going to go through our y-intercept. Then it says 1/2 inches equals 5 feet. So the inches are going to be our x value. So 1/2 equals 5 feet. So if 1/2 equals 5 feet, how do I get to 1? So I have to double 1/2 to get to 1. So I need to double 1/2 in y. So 1 would be twice of 5 is 10. And then let's go ahead and do 2. So if 10 divided by 1 is 10, then 20 divided by 2 for our constant would be 2. So 10 divided by 1 is 10. right? And 5 divided by 1/2. That's what we were looking for. So if you do up here, 5/1 divided by 1/2, to divide fractions, you multiply by the reciprocal. So we're going to keep, change, flip. So 2 times 5 is 10. 10/1, we can cross that out. It's just 10. So that means I'm going to multiply my constant times x to get my y. So 3 times 10 is 30. So now that I have my table done, let me find a graph that matches. So this first graph has of course, they all go through the origin. So 1 and 40 is my first point on that. That's not what I'm looking for. So no. And then the second one has 1 and 80. So no. This next one has 1, and it looks like 10, so maybe. I'll check more points on that one. And this one has 1 and 20, which is not correct either. Let's go ahead and check the rest of our points. So 2 and 20. Oh, darn thing. Okay. 3 looks like about 30. So 4, we said, would be 40. Is that what it shows? 4 and 40. 2 and 10. Okay, that looks right. So this here is going to be our answer. Let's try one more together. A local shipping company charges 65 cents an ounce for shipping a package within the state of Texas. Which table represents the same relationship between the weight of the package and the price to ship it? So it's 65 cents per ounce. So let's go ahead. All right, let's think about this. We're looking at price and we're looking at ounces. Those are our 2 units. So does the price, is that going to be our dependent or independent? So, right, the price is going to be our dependent variable because the price depends on the number of ounces. So ounces are going to be our independent variable. So which is independent, x or y? So independent is x, y is dependent. So 1 ounce, an ounce it says, is 65 cents. So 2 ounces is 2 times the 65. So 0.65 times 2. 2 times 5 is 10. 2 times 6 is 12, plus 1 is 13. 2 numbers to the right of the decimal, so $1.30. That's a decimal there. Kind of looks like a negative. Sorry. Okay, and then it goes up to 4. So if 2 times 65 cents is $1.30, I can just double $1.30 to get to 4. So $2.60. I doubled my 1 and I doubled my 3. And then to get up to 6, I can add my value for 2 and 4. So 2 plus 1 is 3.90. So let's do 8 as well. So for 8, I can multiply 0.65 times 8, or I can double my amount for 4, but either way. So 8 times 5 is 40. 4 times 8 is 48. Plus 4 is 52. 2 numbers to the right of the decimal, so $5.20. So now that I have my table, let me find the correct match. So I know this one's wrong because 2 ounces is 130 and they're not all the same. Let me look at F. F, 65 cents. Well, it's 65 cents an ounce, not 2 ounces, so no. Number 2 has $1.30 for 2. That's right. $2.60 for 4, that's right. $3.90 for 6, that's right. $5.20, that looks right. Let me double check the last one. 2 ounces is $1.30. 4 ounces is not $1.95. So that one's wrong. So our answer here is G. Okay, guys, that's it.